as I mentioned before, in order to run this kind of program on the cluster, we have to submit a job to the cluster. So the jobs are controlled by specific configurations, job configurations. So in order to run the MapReduce program, we have to set these configurations. So configuration.set MapReduce job name, and then we give the name of our program application that we wrote. So in this case, it's my app. And we can add values to the configuration. These values are of our arbitrary choice. So in this case, it added full and 12. And this is once your program is set and you can add values to it. So in order to run this program, we are creating a launching program for the application. The launching program will configure the mapper and the reducer, and the output key and value types, and also it will set the location for these outputs. And so this launching program will, after all these configurations are set, it will submit the job to the cluster and wait until it is completed. So that is all that it happens. This is how we set the configurations. So configuration set the job name, and we will say what the job is. In this case, it's the word count. Set the output key class, the output value class, the mapper class. So we can we're gonna talk in a moment about these combiners, but these are like helper functions that can be used after the mapper runs and before the result is given to the reducer. So those combiners are sub-tasks of mappers. Let's say we can combine the same words together before giving them to the reducers. Then we can set the input and output format and the path. So where we're going to place where we will get the data input files and where we're going to place the output files. And finally, we can submit this job to the cluster. So that is how we can run it, and we're going to do this as an exercise next time. So what are these input-output formats? We can specify how the input can be read and how the output can be written. So default is a text format, which is flat text file, one by one. Another option is to have a binary output. So it is creating a text file or a binary file. How many mappers and reducers are we gonna get? So this pretty much depends on the data. The last time we talked about a block. The block that we have seen was 64 megabytes. And I said that is the size of a block which is placed on the disk. And if the file is larger than that, it's gonna take several blocks. If our data is huge, it's gonna take many blocks. If it takes more than one block, you're going to get another mapper. So for every block, there might be a new mapper. So if the data is more than, if the block is 64 megabytes, and if the data is bigger than that, we will get two mappers. That can be changed. You can, so the Hadoop can be configured to what block size to use, and if you want, you can set it to 1 megabyte, and then you're gonna get more mappers. But that pretty much is automatically decided by Hadoop how many mappers you're gonna get. So usually it's the number of blocks, but it can be changed by changing the size of the block. So that is the hint. There is a way to compute it. The reducers are 0.95 times the mapper tasks, or the maximum mapper tasks that we could get. The reducers are less than the mappers. So I mentioned we can have this combiner helper tool, which we can use before the intermediate output is given to the reducers. Other tools, there are other tools. There are counters, partitioners, and we can also do compression. But these are several tools that can be used. So what are partitioners? Partitioners are applications that can define how the keys are assigned to the reducers. Usually the keys are spread out randomly to the reducers, but if we don't like that, we can use these partitions to implement our own logic to say how the keys should be assigned. So we can have custom partitioning. For example, if we want to produce total order in the output. Otherwise, the order will be random. So this is what these are used for. Configuration, set partitioner class, and then you can define in here what we want to do with the order of the reducers. These combiners, as we said, because when we were doing the word count, and there are many of the same words in the mappers, we can use a combiner to combine them together before giving them to the reducers. And the reason we do that is to decrease the size of the data that is being transferred through the network. Because every time I transfer a word and its count, it's transferring data. But if I just transfer the word and combine all the words at the same time, instead of transferring each word separately, it's going to transfer at one time with the count for all of them. And that is reducing the network traffic, so it is speeding up the job, the computation. Compression, same thing. If we compress the data that is being sent through the network, we will achieve faster processing. So compressing the outputs and intermediate data leads to a huge performance gain. There is a way to specify that. Compress the map output. If we want to compress the job output, we can set that parameter to true. So these are some helpful tools. There are many other tools. For example, a counter and the ones that we listed here. So counters, there could be 0 reducers. If we don't want them for reducers, we don't have to have them. So we can just say we don't want that. Or we can try to cache some data which is being transferred many times. Instead of transferring it, we can cache it. So this information on each node that will be doing the processing. So these are some handy tools that can speed up the computation.